Okay, this is practice test solutions video 1. I'm not sure how many videos there's going to be, but we'll go in order here. I'll get as many done as I can. Determine whether each description refers to an acidic, basic, or neutral solution. Is purple with cabbage juice? Well, cabbage juice itself is purple. If it doesn't change colors, that means it's neutral. Okay, has a pH of greater than 7. Has a pH of greater than 7. Remember, the pH scale goes from 1 to 14. Anything above 7, so 7.01, is going to be basic. Often tastes bitter, basic. Lye, drain cleaner, sodium hydroxide, NaOH, is basic. A solution of HNO3, well, H right there means it's an acid. H plus equals OH minus. So if the concentration of H plus is equal to the concentration of OH minus, well, what do we really have there? We have H2O, don't we? H2O is water. Water is neutral. H plus plus OH minus, H2O, neutral. Okay, section 2, multiple choice. Select the best answer for each question, 1 point each. Okay, each of the following can describe an aqueous solution with a strong electrolyte, except, this is a tricky question because it's saying it can describe. It's not saying it's the definitive explanation, but it's saying it can describe. So you guys see which one of these answers falls into this description of a strong electrolyte. The solute dissociates completely into ions. That's true. The solute is a covalent compound. Well, it could be covalent, but it also could be ionic, right? So for an example, sodium hydroxide is a strong electrolyte, but it's not a covalent compound. It's ionic. The solute is a strong acid. So in other words, here's how you would look at this. Are all strong acids strong electrolytes? Yes, they are. The solution contains a large amount of ions. Do all strong electrolytes contain a large amount of ions? Well, they're good conductors. Yes, they do. Okay, so this is your correct answer. That's the one that is ambiguous. It's not definitive because it could be a covalent compound. It could also be an ionic compound. Number 7, which of these compounds does not dissolve in water? Okay, to answer this, you're going to have to go back to your solubility table in the back. So we've got ammonium phosphate. All ammonium compounds are going to dissolve in water. Ammonium phosphate is aqueous, so that one will. Calcium carbonate. Here's calcium, and there's carbonate. Calcium carbonate will not. So we'll go ahead and leave that blank for a second. But let's check the rest just to be sure. Oops. Let's see. Potassium chromate. Potassium, and all potassium salts will dissolve, so that will. And zinc nitrate. Go down to zinc and let's look at nitrate. There is zinc, and let's find nitrate. I just skipped it, I think. There it is. Zinc nitrate will dissolve, so the only answer is letter B. That's going to be calcium carbonate. Okay, this is asking for concentration. So what are they asking you to do here? They're asking you to find molarity. Let's read it. What is the concentration of a solution made by dissolving 12 grams of sodium hydroxide in enough water to make a 0.5 liter solution? So remember, molarity, big M, equals the number of moles divided by the volume in liters. Volume in liters. Okay, so let's go ahead and do this. We've got grams of sodium hydroxide. What are we missing? We're missing the number of moles. So here's how you do that. 12 grams of NaOH over 1. We convert this to moles. And molar mass is 40 grams. 40 grams per 1 mole. So 12 divided by 40. I'll have to do that math right now. One moment. Oops. Okay, I just did the whole thing without recording it, so here it is one more time. 12 grams of sodium hydroxide, and each mole of sodium hydroxide is 40 grams. So when I convert that to moles, I got 0.3 moles. And I divide that by my volume, in this case is 0.5 liters. 0.3 divided by 0.5, as you can see here, is 0.6. And that gives me letter A. Okay. So again, what did I do? I just converted my grams of sodium hydroxide into moles, and then I divided it by liters of water, 0.5. Okay, number 10. If 50 mils of a 200 ml sample of 0.1 molar sodium chloride is spilled, what is the concentration of the remaining solution? Okay, I'm going to get a piece of paper and solve this right now. Okay, this sounds like a trick question, and it is. There's some extra numbers in here that you don't need anything to worry about. What's the concentration of the remaining solution? Well, it doesn't matter. Okay, whatever's left over is going to be it's going to have the same concentration. You could pick that number, you could pick that number, it doesn't matter. Okay, it's going to have the same concentration. All right, but anyway, for argument's sake, let's just say, what is the concentration of the remaining solution? 50 mils of 200 ml sample was spilled. So what's left over? We got 150 mils of solution. Well, that equals 0.150 liters over 1. Okay? And now we're going to go from liters to, what are we going to go from? Liters to moles. Okay, so you got let me just see one thing. One moment. Look at that. They got me. Even after I knew it was a trick question, they still got me. I started to do this math, and I said, well, wait a second. Liters to molarities. Wait, they're asking you for the concentration. I just told you it's the same concentration. You don't even have to do any math. Here it is. It's a 0.10 molar concentration. There you go. You don't even have to do this. You see that? It pays to reread and stop and think. All right? They got me. So your answer is C. Yeah, the concentration will not change. Okay, just because you spill something doesn't mean the concentration of either what you spilled or your original solution changes. It's still the same concentration. Good question. Number 11. List the following solutions with an unknown solute in increasing concentration. 0.1 grams of solute in 500 mils of solution. 0.1 grams of solute in 250 mils of solution. And 0.2 grams of solute in 250 mils of solution. Okay, so we've got 0.1 grams in 500, 0.1 grams in 250, and 0.2 in 250. Well, if you look at, let's just start by looking at this, 0.1 grams in 500 versus 0.1 grams in 250. What's going to be more concentrated? This is going to be more concentrated than that is, right? And 0.2 grams of solute in 250 mils. Well, we've got the same volume here, okay, but we've got double the solute. So this is going to be more concentrated than this. So that's going to be the first most concentrated, and then we're going to go back and see what order they want us to put it in. That's the second most concentrated, and this is the third most concentrated. Okay, so now list the following solutions with an unknown solute in order of increasing concentration. So 1, 2, and 3. So it's going to be Z is greater than Y, which is greater than X. But they don't have it that way, do they? They've got it written backwards. So Z is greater than Y, which is greater than X, which is going to be letter A. Again, notice Z is greater than Y, which is greater than X. The other way of saying this is X is less than Y, which is less than Z. You got to be real careful with this now. Okay? Do it just the way that I did it there. You can also divide it too. You can take 0.1 divided by 500, 0.1 divided by 250, and 0.2 divided by 250, and you'll get numbers so you can see that as well. But the real trick here is to be careful. Look how they have this sequenced, okay? All right, number 12. 100 ml sample of solution with a concentration of 5 molar is diluted by adding 300 mils of distilled water. The new concentration will be, okay, this is a dilution problem. Okay, I'm going to go ahead and stop and solve it in the next video because I'm running out of time here.